All right. Hey, everyone. Thanks for tuning in. We always love getting your suggestions for topics to dig into. And lately, we've been seeing a lot of questions about something pretty specific, but super relevant to, well, basically everyone who uses the internet.
Yeah, it's one of those things you might not think about much until you hit it head on, and then it's like, wait, what's going on here?
Exactly. And that thing is HTTP 429 errors, those too many requests messages you sometimes get. And it all ties into this concept of rate limiting, which websites and apps use to manage how much traffic they can handle at once. So for this deep dive, we're going to unravel what these errors mean for you, whether you're just browsing the web, building a website, or thinking about online security.
Totally. And we've got a great resource to guide us. It's a piece by Nick Webson, a lead software engineer over at Rebrowser. He really knows his stuff when it comes to web technologies.
For sure. And in this guide, he breaks down why these 429 errors happen, how to deal with them when they pop up, and crucially, what developers can do to prevent them in the first place.
Right. So our goal today is to extract the most important insights from Nick's guide so you can walk away understanding why you encountered these errors and what's going on behind the scenes to manage the flow of all that data flying around the internet.
Perfect. Let's get into it. So first things first, what exactly is an HTTP 429 error in plain English? Like, what's happening when you see that message?
Okay, so in the simplest terms, an HTTP 429 error means a server. The computer that hosts a website or an app is basically telling you, whoa, hold your horses. You're sending me too many requests too quickly.
So it's like a digital slowdown sign.
Yeah, exactly. It's the server's way of saying, I can't keep up with you right now. Give me a moment to catch my breath.
Gotcha. Now, why do we even need this kind of mechanism? What's the point of having these limits?
Okay, picture this. Imagine a super popular online store having a massive flash sale.
Black Friday, Cyber Monday, that kind of thing.
Exactly. Now, if thousands of people all try to buy stuff at the exact same time, the website's servers can get completely swamped.
Yeah, I've definitely experienced that. Pages loading super slowly, errors popping up.
Right. And in the worst case scenario, the whole site could crash. So these 429 errors, they act like a sort of safety valve. They help prevent that digital stampede and make sure the server can keep running smoothly for everyone.
So it's like a crowd control measure, but for websites.
Precisely.
Okay, so how often do we actually run into these errors in our everyday browsing?
Well, more often than you might think, actually. According to Akamai's 2024 State of the Internet report, around 3% of all HTTP errors you encounter are related to rate limiting.
Wow, 3%. That's actually a pretty significant chunk.
It is. It really shows you how important rate limiting is for keeping the internet running smoothly.
So let's talk about what actually triggers these too many requests messages. The guide dives into a few specific scenarios. What are some of the most common culprits?
Sure. One of the big ones is API rate limits. A lot of online services have these APIs, which are like interfaces that let different apps and programs talk to each other and exchange information.
Right, like when you use your Facebook account to log in to another app.
Exactly. But to prevent one app from hogging all the resources, these services often set limits on how many times an app or a user can make requests within a specific time frame.
So it's like setting a speed limit for how quickly apps can talk to each other.
Yeah, you could think of it that way. And the guide gives a good example using Twitter's API. For a regular user, you might be limited to something like 500 requests every 15 minutes.
So if you have an app that's constantly checking Twitter for updates, it could hit that limit pretty quickly.
Absolutely. And that's when you'd start seeing those 429 errors.
Okay, what other scenarios can lead to a 429?
Another major reason is server resource protection. Think about it. Every server has a finite amount of processing power, memory, and bandwidth.
Like the physical limits of the hardware.
Exactly. If a server gets bombarded with too many requests all at once, it can start to run out of these resources. This can lead to slowdowns, errors, or even a complete crash. Rate limiting acts as a safeguard to prevent the server from getting overloaded and essentially burning out.
So it's about managing the workload and making sure the server doesn't get overwhelmed.
Exactly. It's like having a bouncer at a nightclub who makes sure not too many people are trying to get in at the same time.
Right, to avoid chaos and keep things running smoothly. Makes sense.
And what about security? Does rate limiting play a role there?
Absolutely. In fact, security measures are one of the key triggers for rate limiting. Nowadays, you have automated systems that constantly monitor website traffic for any suspicious activity.
Like what kind of suspicious activity?
Well, for example, if they detect a massive spike in requests coming from a single IP address, which is like your internet address, that could be a sign of a malicious attack. Like those DDoS attacks you hear about, where they try to flood a website with traffic to take it offline?
Exactly. Or it could be someone trying to brute force their way into an account by repeatedly guessing passwords. Rate limiting can kick in to automatically block or slow down this kind of suspicious behavior. It's like a first line of defense against attacks.
So it's like a digital security guard who's always on the lookout for trouble.
Yeah, that's a good analogy.
Okay, cool. The guide also mentioned something about limits on connections. Can you explain that a bit?
Sure. This is about concurrent connection limits. Many servers have rules about how many simultaneous connections they'll accept from a single IP address.
So how many devices or tabs you can have open on a website at the same time from the same internet connection?
Exactly. The reason for this is to prevent one user or a small group of users from hogging all the available connection slots and impacting everyone else's experience.
Right, so one person doesn't end up slowing down the whole site for everyone else.
They-
Okay, we've got a pretty good grasp on why these 429 errors happen. Now, the guide talks about some smart solutions for handling these limits when they're hit. What are some of the key ways systems deal with this?
One of the most common and effective strategies is called exponential backoff. It's a fancy name, but the concept is actually pretty simple.
Okay, break it down for us.
So imagine your computer or your app tries to access a website and it gets a 429 error, meaning it's hit a rate limit. Now, instead of immediately trying again and potentially making things worse, it waits a little bit before retrying.
Okay, so it takes a pause.
Right, and here's the key. If it gets another 429 error, it waits even longer before trying again. And if it fails again, it waits even longer, and so on. So the waiting time increases exponentially each time it gets rejected up to a certain point.
It's like, okay, I'll wait a second. Nope, still busy. Okay, I'll wait 2 seconds, still no. All right, 4 seconds this time.
Exactly. And this gives the server some time to recover and reduces the chances of you just overwhelming it with repeated requests.
Right, because if everyone just kept hammering the server, it would never have a chance to catch up.
Exactly.
The guide actually includes a bit of code in JavaScript showing how this works in practice.
Yeah, that code snippet was demonstrating a modern implementation of exponential backoff. It had some nice features like built-in error handling and logic for automatically retrying the request after the appropriate waiting time.
And I remember you mentioned something about a special header that some servers send, along with the 429 error.
Right, that's the retry after header. It basically tells you exactly how many seconds you should wait before trying again. The code also had a maximum waiting time to prevent it from waiting indefinitely if the server's having major issues.
Okay, that makes sense. So the key takeaway here is to be patient and give the server some breathing room. Don't just keep hitting that refresh button.
Right.
Now, let's talk about scaling things up. What happens when you have a large application that runs on multiple servers? How do you manage these rate limits across all those different machines?
That's where distributed rate limiting comes into play. The guide mentioned using a system called Redis for this. Redis is a type of database that's really fast and efficient because it stores information in memory.
So it's like a super speedy note-taking system for the servers.
Yeah, you could think of it that way. So when you have multiple servers handling requests, you need a central place where they can all share information about how many requests are coming from a particular user or IP address. Redis provides that central point of coordination.
So all the servers can check with Redis to see if someone is hitting their limit, regardless of which server they happen to connect to initially.
Precisely. That's the key to making distributed rate limiting work effectively. And the code example in the guide illustrated how you could track requests from a specific IP address within a set time window. In that example, it was 100 requests per hour. Redis keeps track of all the recent requests, and if someone goes over the limit, it triggers the rate limiting mechanism.
That makes sense. So it's all about having a shared memory system that all the servers can access to coordinate these limits. Now, the guide specifically highlighted WordPress websites, which are often targeted by automated attacks. What are some of the ways WordPress sites can use rate limiting to protect themselves?
Yeah, WordPress is definitely a popular target for attackers. One important protection measure is advanced login protection. The guide gave an example using Nginx, which is a common web server software.
Right, I've heard it in Nginx.
So the Nginx configuration showed how you can restrict the number of times someone can try to log in from the same IP address within a short period. For instance, you could limit it to 1 login attempt per second with a little bit of flexibility for a quick burst of attempts. This makes it much harder for automated attacks that try to guess passwords by rapidly trying different combinations.
So if someone is trying to hack in by rapidly entering different passwords, they'll quickly get get locked out for a bit.
Exactly. It's a simple but effective way to deter those kinds of attacks.
The guide also mentioned some extra security settings in that Nginx configuration. Can you tell us about those?
Sure. Those settings like XWAM options and XXS protection are additional security headers that help protect against other types of web vulnerabilities.
So they're not directly related to rate limiting, but they're good security practices to implement alongside it.
Exactly. They add extra layers of protection to make the website more secure overall.
Got it. What else did the guide suggest specifically for WordPress sites?
Well, optimizing plugins and themes is crucial. The guide mentioned that they analyzed a lot of WordPress sites and found some common patterns. One key takeaway was to regularly audit the plugins you're using to make sure they're not making unnecessary requests to external services or causing conflicts that could strain your site.
Right, because a poorly coded plugin could end up generating a lot of extra traffic.
Exactly. Another recommendation was to implement caching using tools like Redis or Memcached.
And caching, that's basically like storing copies of frequently accessed data so the server doesn't have to regenerate it every time.
Right. Exactly. It can significantly reduce the load on the server.
Cool. Any other tips for WordPress optimization?
Well, making sure your database queries are efficient can also help. And opting for lightweight plugins that don't consume a lot of resources can also make a difference.
So it's all about making your WordPress site run as smoothly and efficiently as possible.
Right.
Now, for really large applications that handle huge numbers of users, the guide talked about enterprise-level monitoring and prevention. What does that look like?
At that scale, you're dealing with a whole different level of complexity. You need a much more sophisticated approach to manage rate limiting effectively. This usually involves a combination of several strategies.
Like what?
Well, first, you need real-time analytics to constantly track the patterns of requests coming into your systems. This helps you identify any unusual spikes or anomalies that could indicate problems.
So it's like having a dashboard that shows you all the traffic flowing through your systems.
Yeah, exactly. Then you have automated scaling, which is especially crucial if you're using cloud services. This means automatically adding more server power when demand goes up and scaling back down when things are quieter.
So it's like having a flexible system that can adapt to changing traffic patterns.
Precisely. Another key element is smart bot detection. As the scale increases, it becomes even more critical to distinguish between real users and automated bots, some of which might be malicious.
So you need to be able to tell the good bots from the bad bots.
Right. And finally, many large-scale systems use something called circuit breakers. These are mechanisms that can temporarily stop requests from going to a particular part of the system if it's experiencing problems.
That sounds interesting. Can you explain how circuit breakers work?
Sure. It's actually a similar concept to circuit breakers in electrical systems. If one part of the system is getting overloaded or experiencing errors, the circuit breaker can trip and temporarily isolate that part.
To prevent the problem from spreading to the rest of the system.
Exactly. It's a way to contain issues and prevent a small problem from cascading into a major outage.
That's a really clever way to manage complex systems. The guide also briefly touched on future-proofing applications in terms of rate limiting. What are some of the emerging trends in this area?
Yeah, the field of rate limiting is constantly evolving. One interesting area of development is machine learning-based adaptive rate limiting.
Oh, that sounds cool. So using AI to manage rate limits.
Exactly. The idea is to have systems that can learn what normal traffic patterns look like and automatically adjust the rate limits in real time based on what's happening.
So instead of having fixed limits, the system can dynamically adjust them based on the current situation.
Precisely. Another trend is using edge computing for rate limiting.
Edge computing, that's about processing data closer to the users, right?
Right. So instead of having all the rate limiting logic centralized in one place, you can distribute it to servers that are physically closer to the users.
That makes sense. It can reduce latency and improve performance.
Exactly. We're also seeing the development of more sophisticated algorithms like token bucket algorithms, which provide finer control over the rate of requests.
So it's like having a more precise way to control the flow of traffic.
Right. And then, of course, there are serverless architectures, which are becoming increasingly popular. Serverless platforms can automatically scale up and down based on demand, which can help with managing sudden surges in traffic.
So it's like having a system that automatically expands and contracts as needed.
Precisely.
Okay, let's shift gears a bit and talk about what people are experiencing out there in the real world. The guide mentions some interesting community insights from online discussions. What were people sharing about their experiences with 429 errors?
One observation that came up frequently was that people often encounter clusters of 429 errors. Everything might be working fine for a while, and then suddenly there's a wave of these errors.
So it's not always a constant thing. It can come in bursts.
Right. And often this suggests that the companies providing those online services might be making changes to their rate limiting rules or updating their infrastructure.
So it could be a sign that things are happening behind the scenes that are impacting those limits.
Exactly. It highlights the dynamic nature of rate limiting.
It's good to know. It means that it's not always something you're doing wrong as a user. It could be changes on the server side.
Absolutely.
What other insights did the online community share?
Another interesting point that came up was the unexpected role of browser extensions in sometimes triggering 429 errors. It turns out that certain extensions, especially those that prefetch content or make background requests, can contribute to hitting rate limits.
Wow, I wouldn't have thought of that. Can you give some examples?
Sure, some weather extensions or tools that preload web pages to make them load faster can actually end up making too many requests in the background, especially if you have multiple tabs open.
So the extension that's supposed to be making my browsing faster could actually be causing these annoying errors.
Yeah, in some cases that's possible. And people have come up with workarounds like temporarily disabling extensions on certain websites or creating custom rules in their ad blockers to block these extra requests.
Interesting. So it's something to be aware of if you're experiencing a lot of 429 errors.
Right.
The guide also mentioned a controversial perspective that's been floating around. What's that about?
Yeah, this is an interesting one. There's some speculation in the tech community that some companies might be strategically using stricter rate limiting on older versions of their services as a way to encourage users to switch to newer platforms or interfaces.
Oh, that's a clever tactic, if true. Like make the old version less enjoyable to use so people are more likely to upgrade.
Exactly. Now, it's important to note that this is mostly speculation, and there's no official confirmation from any company that this is happening, but it's an interesting idea that's definitely being discussed among developers.
It makes you wonder what other subtle ways rate limiting might be used.
For sure.
So what practical advice does the community offer for dealing with these errors?
Well, there are some temporary workarounds that people have found, like trying incognito mode, which gives you a fresh start without your usual browser extensions and cookies, or using browser extensions that offer local caching.
So little tricks to try and bypass the limits.
Yeah. But the consensus among experienced developers is that these are just quick fixes. The real solution is for developers to design their applications with rate limits in mind from the very beginning.
So it's about building applications that can handle these limits gracefully.
Exactly. And a key recommendation is for developers to use the network monitoring tools that are built into most web browsers. These tools can show you exactly how many requests your application is making, which can help you identify potential rate limiting issues early on.
That's great advice. So while there might be some Band-Aid solutions on the user side, the real solution is to build applications that are designed to work well within these limitations.
Right.
Okay, as we wrapped up this deep dive, what's the key takeaway you want listeners to remember about HTTP 429 errors and rate limiting?
I think the main point is that managing these errors effectively is crucial for keeping online services healthy and ensuring a good experience for everyone. And it involves a multifaceted approach.
What do you mean?
Well, on the server side, it's about setting appropriate limits, actively monitoring traffic to catch any unusual patterns, and being prepared to adapt to changing demands. On the application development side, it's about building systems that are efficient, can handle rate limiting gracefully, and can scale effectively as needed.
So it's a combination of proactive planning, smart design, and ongoing monitoring and adjustments.
Exactly.
And for anyone who wants to dive deeper into this topic, the guide pointed us to some great resources.
Yeah, if you're interested in the technical details, check out RFC 6585, which is the official document that defines the HTTP 429 status code. You can also find great real-world examples of rate limiting in action by looking at the API documentation for platforms like GitHub. And if you're interested in building your own rate limiting solutions, the Redis documentation has excellent resources.
Fantastic. We'll make sure to include links to all of those in the show notes.
Great.
So, as we finish up, here's something to ponder. This ongoing balancing act between protecting online services with limits and ensuring a smooth, uninterrupted experience for users is a dynamic challenge that's constantly evolving.
Absolutely.
Understanding these technical details can not only help you make sense of those too many request messages, but also give you a deeper appreciation for the complexities of the internet and all the mechanisms that work behind the scenes to keep things running.
It really highlights the invisible infrastructure that makes our digital world possible.
Right. So next time you encounter a 429 error, think about what might be going on behind the scenes. And remember, it's all part of the intricate dance of keeping the internet up and running for everyone.
Well said.
Thanks for joining us for this deep dive. We'll catch you next time.